Welcome back, children. Welcome to Refresh Concepts with me, Dinesh Modi. Let's proceed further with all important theorems of circle. Now, what we have written over here is inscribed angle theorem, and I have given you two statements of it. The reason behind it is the first statement is accepted in many boards. The second one is accepted in many boards, mainly ICSE, this one. This is accepted in many boards. Both are talking the same. Conceptually, they are the same. So I want you people to understand the difference also and understand why they are similar to each other. Only the language is different, bit different. That is what, everything is what I'll make you understand what difference they are in, or rather what difference they are having it. As I said, they are having difference in their language. So I'll point out that also. But let's understand, right, what both the statement has to say. In general, we say it's an inscribed angle theorem. Now, we have been given a circle, right? I'll explain this also, what is there in the circle. Let's read the first part. The measure of the inscribed angle is half the measure of its intercepted arc. Measure of the inscribed angle is half the measure of its intercepted arc. So let us understand first of all what is an inscribed angle. The angle so formed on the circumference of the circle by an arc is termed as an inscribed angle. So if I say arc BXA is one of the arc, is that arc subtending or forming an angle BAC on the circumference of the circle? So angle BAC is termed as an inscribed inscribed angle. What is angle BAC termed as? Angle BAC is termed as inscribed angle. Inscribed angle is half the measure of its intercepted arc. The arc which is forming the angle at the circumference, this arc is termed as an intercepted arc. So BAC is an inscribed angle, BXC is termed as an intercepted arc. BAC is an inscribed angle, BXC is termed as an intercepted arc. So I just told you and I just made you understand what is the difference between the intercepted arc, or rather what is the meaning of intercepted arc and what is the meaning of inscribed angle. Now let's read the statement. The measure of the inscribed angle is half the measure of the intercepted arc. What is an inscribed angle we have learned? BAC. Half measure arc BXC. Or for that matter, if you take this 2 here, what will I get? Twice of BAC is equals to measure arc BXC. There are many who will say, sir, you have written the same. There is no difference. I also know it is the same. Actual, if you go by the statement, the inscribed angle is half the intercepted arc. Or the other way around, twice the inscribed angle is the intercepted arc. Now, why did I tell you and give you the second answer? You will get to know. In this video only, you will get to know, okay, why am I using two languages for the same statement? Right, children? Once again, inscribed angle is half intercepted arc. Or twice inscribed angle is equal to intercepted arc. Second thing, angle subtended by any arc at the center is double the angle at any point on the circumference of the circle formed by the arc. So if I take the same arc BXC, what is the angle formed at the center by the arc BXC? Is BOC. They say angle subtended by an arc at the center. So this is the angle, BOC is the angle subtended by an arc at the center, is double the angle at any point on the circumference. Angle BAC is one of the angle formed on the circumference of the circle formed by the same arc. Again, BXC is only forming that arc BAC. So if I write down to prove wise, what we are supposed to prove, measure angle BOC is twice measure angle BAC. Measure angle BOC, entire BOC, is twice BAC. Or if I bring this here, BAC, and if I bring this here, can I say BAC is half of BOC? If I shift this to here, can I say BAC is half of BOC? Again, I have used two options, here also two. Are we good to go? Let's start and understand. And by the time I finish off my video, you'll get to know why they are the same and what difference they have in language. Let's start. Let's start. So now what we are going to do is, we are going to say join OB, join OC. Join OB, join OC. When I join OB and join OC, step by step, in triangle OAB, in triangle OAB, is OB equals to OA, radii of same circle? So if OB is equals to OA, then can I say the base angles are equal? So which angles I'm talking about? I'm talking about these angles. Angle 1 congruent to angle 2. Likewise, in triangle OAC, OC equals to OA, radii of same circle. OC equals to OA in triangle AOC. Can I say angle 3 is equals to angle 4? Now children, before I proceed further, one thing is what I would like to make you people understand. In any board you go to, when we have circle, tangent, secants and chords, all these theorems will be there in your textbook, right? So I want my children to learn today, refresh your concepts, reinvent learning. We are not going to write down the entire proof, mind you. I'm giving you something called as from my side. Mind you, it is from my side and it is my language, skeletal solution. When I say skeletal solution, mind you, it's a very abnormal word which you all are coming across. You might be thinking, sir, what exactly skeletal solution is? But just tell me that a complete body is made up of first skeleton, and then the skeleton is covered by muscles, tendons, ligaments, right? And the organs to get the entire organ body. What I'm going to give you is answer in 1, 2, 3, 4. So statements are nothing but muscles, ligaments and tendons. I shall give you a skeletal answer in terms of 1, 2, 3, 4. Thereafter, you can fill up all the muscles, ligaments, means you can fill up the statements, reasons, and if combined together, what you get is nothing but an organ body, which is theorem. That is the thing which you are going to learn in refresh concepts. As I said, reinvent learning is what we say. If you can't understand a particular sum in geometry, always try to get the answer in skeletal form and then fill up with reasons and statements and see how the things work. So you will in the next 10 minutes or so. Let's start once again. What did we do so? In triangle OAB, OA equals to OB, radii of same circle, angle 1 congruent to angle 2. OA equals to OC, radii of same circle, angle 3 congruent to angle 4. Now what? Can I say angle BOX, which is angle phi. Angle BOX, which is angle phi, an exterior angle for triangle OAB. I repeat, BOX, that is angle phi, is an exterior angle for triangle OAB. So are we aware about that remote interior angle property for a triangle? Exterior angle of a triangle is equal to sum of the remote interior angle. Exterior angle for a triangle is sum of the remote interior angle. I'll write down everything skeletal wise. I shall write down everything skeletal wise. So we start our solution or proof for that matter. We start our proof now. We have stated angle 1 equal to angle 2, equation number 1 by isosceles triangle theorem. As I stated, we are not giving you the entire theorem, mind you. We are giving you only the skeletal solution to understand the concepts. Angle 1 congruent to angle 2, equation number 1, reason, isosceles triangle theorem. Angle 3 congruent to angle 4, reason, isosceles triangle theorem. Next, now angle phi. Angle phi is exterior angle. Is exterior, I'm writing shortcut, is exterior angle of triangle which AOB. So by remote interior angle property, can I say angle phi is equals to angle 1 plus angle 2? Any problem? Any problem? Angle phi, remote interior angles. So exterior angle, remote interior angles are these. Next, whatever I did for this one, can I say the same thing getting applied for this one also? So who is an exterior angle over here? COX is an exterior angle of triangle AOC. So when you write down, you have to write down all these things and not in the skeletal format. 1, 2, 3, 4. COX is an exterior angle of triangle AOC. Therefore, angle C is equals to angle 3 plus angle 4. This is equation number 3. This is equation number 4. In each of the case, I can say we have applied remote interior angle property or theorem, you can say. Property or theorem, you can say. If you want, you can write down the entire statement. Exterior angle of a triangle is equal to sum of its remote interior angle. Now what, children? Now I shall look into my question what exactly I want. So first we are proving, what we are going to prove, we are going to prove the second part first, and then I'll make you understand. So BOC is twice BAC. So I don't know how to get BOC. So I'm going to ask question to the question itself. Learn, children, whatever I'm making you understand. This is how geometry will become very, very easy. Learn to ask question to the question. I reiterate, learn to ask question to the question, and the question has to answer. It is a question has to answer. So I'm asking the question. Question, measure angle BOC means what? Oh, measure angle BOC is nothing but adding 5 and 6. Measure angle BOC is nothing but adding 5 and 6. That tells me in order to get BOC, I have to add 5 and 6. In short, I will go for adding 3 and 4, equations 3 and 4. So I shall say adding equation 3 and 4. When I add equation 3 and 4, what will I get? I will get angle 5 plus angle 6. I have added the LHS. Angle 5 plus angle 6 is equals to angle 1 plus angle 2. Now children, angle 1 and angle 2 are equal. So rather saying angle 1 plus angle 2, can I say angle 1 plus angle 1? Because angle 1 and angle 2 are the same. They are equal. Likewise, adding 3 and 4 also, we need to add the LHS also, and we need to add RHS also. So when I say 1 plus 2 plus 3 plus 4, I shall say 1 plus 1. Likewise, 3 and 4 are also equal. Can I say 3 plus 3? Why? Because 3 and 4 both are equal. 3 plus 3. 3 plus 3. So, angle 5 plus angle 6 is 2 times angle 1 plus angle 3. 2 times angle 1 plus, if you can understand, I have taken common. Angle 1 plus angle 1, twice angle 1. Angle 3 plus angle 3, twice angle 3. 2 common, angle 1 plus angle 3. Once again, angle 1 plus angle 1, twice angle 1. Angle 3 plus angle 3, twice angle 3. 2 times angle 1 plus angle 3. Let's proceed now here. We can now say what is 5 plus 6. 5 plus 6 is nothing but BOC. 5 plus 6 is nothing but BOC is twice. What is 1 plus 3? 1 plus 3 is nothing but BAC. 1 plus 3 is nothing but BAC. 1 plus 3 is nothing but BAC. Central angle is twice inscribed angle. Or if you want this statement, you can say angle BAC, I'll write down, or angle BAC is half angle BOC. Are you getting me, children? Right? Once again, let me first make you understand this one. We'll correlate it. It's very simple. Once again, how did we start it off with? Skeletally. In triangle OAB, OA equal to OB, radii of same circle, angle 1 congruent to angle 2 by isosceles triangle theorem. In triangle OAC, OC is equals to OA, radii of same circle, angle 3 congruent to angle 4 by isosceles triangle theorem. Now, angle phi is an exterior angle for OBA. So, 5 is equals to 1 plus 2. Absolutely on the same line, 6 is equals to 3 plus 4. Thereafter, we ask the question, what you want? The question answered, I want BOC. How can I get BOC? Can I say BOC is nothing but 5 plus 6? That's the reason we added. We did not rectify the answer. We asked the question and the question answered. We did not rectify the answer. So in order to get 5 plus 6, we added equation 3 and 4. I got 5 plus 6. But you already know that 1 and 2 are equal. So 1 plus 1. We already know that 3 plus 4 is what we are supposed to write down. But 3 and 4 are equal. Twice angle A, twice angle 1 plus twice angle 3. 2 common. 5 plus 6. But what is 5 plus 6? BOC is twice BAC. BAC is half of. Right, children? Let me give this expression what we have got. Let me give this expression what we have got as one of the equation. Say this is my equation number 5. Say this is my equation number 5. Say this is my equation number 6. You can not have both the equations, but I'm just saying that. Now I'm going to say what? You people are very much aware that angular measure of an arc is equals to its corresponding central angle. Angular measure of an arc is equals to its corresponding central angle. If you want, I'll write down with a different marker so that you will understand it. Angular measure of an arc. Angular measure of an arc is equal to its corresponding central angle. What do I mean now by saying this statement? Those who are not aware will learn. Those who are not aware will learn. When I am talking angular measure of an arc, I am talking about measure arc BXC. When I am talking about angular measure of an arc, I am talking about arc BXC. The angular measure of an arc is equal to its corresponding central angle. What is the central angle formed by this arc? BOC. So, can I say as of now that measure angle BOC, can I say as of now measure angle BOC is equal to measure arc BXC? Measure angle BOC is equals to measure arc BXC. I would like to highlight this once again with a blue marker. Why? Because now the correlations are going to be equation number 7. Children, just pay attention from 7 and 5. From 5 and 7. Instead of writing BOC, can I write down measure arc BXC? So what my answer will be, measure arc BXC is twice angle BAC. Instead of BOC, I am writing measure arc BXC. I have proved it. So instead of BOC, measure arc BXC is twice, or if you want, what I will say, angle BAC, measure angle BAC is half, measure angle BAC is half measure arc BXC. Now if you check my this one, BAC is half arc BXC or arc BXC is twice BAC. Right? I want you to understand now. I want you to understand. Though we are done with our theorem, I want you to understand now. So what was this talking and what was this talking? Sir, it was the same thing. You just gave one correlation and we are done with both the statements. This is talking of inscribed angle in terms of intercepted arc. This is talking about inscribed angle in terms of central angle. Once again, this is talking inscribed angle in terms of intercepted arc. This is also talking about inscribed angle because each of them talks about arc angle BAC. Each of them talks about angle BAC. You can say BAC half of BOC, BAC half of arc BXC. You can just check BAC half of BOC central angle, half of arc BXC intercepted arc. Both are talking of inscribed angle, but one talks in terms of central angle, one talks in terms of intercepted arc, children. Right? So answer is the same. Either of the board you go, the answer will be in this pattern. But I want you to understand. So henceforth, in the sums is what I can use this one, blue one, or the same time I will be using, but every time I'll be writing on the statement because there are some specific board who will not allow you. There are many specific board who will not allow you to mere write down IAT, inscribed angle theorem. There are students who write down shortcuts also. IAT, 100% not allowed. By no means IAT is allowed. You have to write an inscribed angle theorem, but the preferred answer is the statement. If your board says this statement, please, if your board says this statement. Are you getting me, children? Now, if you want to understand, let's take an example. Those who want to understand, let's take an example. That are they same? Let's take an example. So say, somebody says, measure arc BXC. Example, we are done with the proof. Let's take an example. Measure arc BXC, somebody says in the given part, is 160 degree, say. Then you know what is measure angle BAC? As per this, 80. Half of it. Right? As per this, if this is 80, then what is this? Central angle is double the inscribed angle, or inscribed angle is half the central angle. 80, this is 160, and this is nothing but 160 is what is this statement. Angular measure of an arc is equal to its corresponding central angle. Angular measure of an arc is equal to its corresponding central angle. I hope you are understanding both the versions of IAT. Right? These in my purview are versions of IAT. Actually, they are the same. What is the difference? One is talking in terms of intercepted arc and other is talking in terms of central angle. But both have one thing in common, inscribed angle. So here, inscribed angle is half the intercepted arc. Here, inscribed angle is half the central angle. Or the other way around. Here you can say central angle is twice the inscribed angle. Here you can say other way around, that intercepted arc is twice the inscribed angle. Meaning is the same. I hope my children have understood the entire stuff. Moreover, last time I'm saying, right, we haven't given you the entire proof and you are not supposed to write down your proof in boards 1, 2, 3, 4. No. Why 1, 2, 3, 4? Skeletal. Now you need to fill statements, reasons, what I kept on saying. While making you understand, I kept on saying reasons. I kept on saying the triangles. Adding, everything is what has to be filled up. And when you fill it up, you get a perfect structure of an entire theorem. Right?